Okay, so in this video we're going to look at how we can use what we just talked about in the previous video with the vertex form of a parabola to be able to graph a parabola more efficiently. And then we're going to conclude the video by just summarizing some things dealing with translations some more. So what I have highlighted here is what's the important pieces that if you're not using my notes that you want to make sure that you get down in your own notes. So why don't you pause the video so that way you can get this written down and then pay attention to the video as I explain it. So go ahead, pause the video now, copy those down, and hit play when you're ready to listen to what we're going to talk about with this. Okay, so first off, when we go to graph a parabola, the most important thing, the most important part to start out with is the vertex. Because if you get the vertex wrong, the graph is all going to be wrong. So it's very, very important that we get the vertex correct here. So as we go through this, I'm going to be, we're going to use an example here. Let's just, let me see, y plus 3 equals negative 2 times x minus 5 being squared. So let's say I had to graph this equation. The first thing I'm going to want to do, like I said, is find the vertex. Now, just like what you wrote down in your notes, the vertex is the coordinate h and k, which, if you remember from the previous video, a translation is represented with that sub h and k. So that h and k that we were talking about before with your translation is essentially your vertex. So for example, if we go back up and look at this example here with the absolute value, when I moved this absolute value equation 4 units to the right and 2 units down, this vertex here would be at the point 4, negative 2. Which now when you look at it, that would make sense because it's 4 units to the right and 2 units down. So that's where x and y would be on your x and y axis for that vertex. It would be the coordinate 4, negative 2. And again, that's why, even though you didn't have to write this down, that's why we call this the vertex form of a parabola, because y minus k equals a times x minus h squared. The vertex is given to us. Now, when I look at this example, the y plus 3 equals negative 2 times x minus 5 squared. When I look at that, you might be tempted to think that the vertex is going to be negative 5 and a positive 3. But that is not the case. The vertex for this is actually a positive 5 and a negative 3. Now you might be saying, Mr. Murphy, why is that? Because it says negative 5, so why isn't it a negative 5 for our vertex? And it says a positive 3, so why isn't our vertex 3 for our y in our vertex? Well, the reason is look at the equation. It's x minus the value of h. So it's x minus 5. So that gives me my value for h, or the x part of my vertex, is a positive 5. And for the y, or the y minus k, my equation says y plus 3, but in my formula it says it needs to be y minus the value of k. Well, the only thing that would make that positive is if my k was negative. So it tells me that my k is a negative 3. Or a quick, easy way to find the vertex is you look at what's happening to the x and take the opposite of it. So that would be a positive 5. To look to find the value for y in your vertex, look what's happening to the y in your equation, take the opposite of that. So here we get a negative 3. So that's how we find the vertex. But like I said, this is it's crucial that you make sure you get your vertex correct. Now the next thing that we have here in our notes is this idea of the line of symmetry. The line of symmetry is an equation. It's not just a number, it's an equation. And if we look at our parabolas here on the right, you don't have to put this in your notes if you don't want to, but this dashed line is your line of symmetry. The purpose of that is that helps us see where we're going to reflect our parabola. When we go to graph it, we're going to reflect some points over that line. So it's a vertical line, and vertical lines are always in the form x equals something. So the equation for my line of symmetry for the example I'm looking at here would be x equals 5. So I'd have a vertical line going through the point where x equals 5. Now, the last thing we need to talk about is how to find the maximum or minimum value. So if a is positive, if a is greater than 0, a is referring to this number outside the parentheses. If that's a positive number, that means a graph is going to open up, like our two graphs over here on the right. If they open up, that means that your vertex is going to be a minimum value. So k is going to be the lowest point. It's going to be the minimum value for that equation. Or if it's negative, like we have in our equation, it's a negative 2, that tells us that our graph opens down. And in this case, if it opens downwards, this is now your maximum value for y. Because that's the highest point that the graph is going to reach on the y-axis. That would be your maximum value. So let's look at how we could use this now to graph some equations. Let's look at this first one. Y minus 5 equals negative 2 times x plus 3 being squared. So I'm going to start out by finding my vertex. The vertex, remember, is going to be the point h and k. So I look to see what's happening with the x and take the opposite of it. So my x value in my vertex is going to be a negative 3. To find the y value in my vertex, the k, I look at what's happening to the y. It's a minus 5. Take the opposite of that, makes it a positive 5. So there's your vertex. The equation, remember we're looking for an equation here, so it's going to be in the form x equals whatever h is. So it's going to be x equals negative 3. Now, we can tell, too, by the fact that this is a negative 2 in front, that my graph is going to open downwards. That's going to be helpful when I go to graph this. So first, let's graph the vertex, negative 3, positive 5. Now I'm going to do my line of symmetry. Going through the point, x equals negative 3. And now what I'm going to do is I'm going to come up with some values for x and figure out what those values, what the corresponding values for y would be. Now we don't have to just pick a bunch of random numbers. The whole point of this line of symmetry is for me to pick 2 points really close to that line of symmetry. So I'm going to use negative 2 and negative 1. Because this way I know that it's going to give me a more accurate graph if I pick 2 points close to that line of symmetry. So, and you want to pick 2 points either to the right or to the left, but you don't want to straddle it. So you don't want to say, well, I want to pick negative 2 and negative 4. The reason why is, let's just say that if I get negative 2 as a positive 4 for y, well, the fact that I know this is my line of symmetry tells me automatically that that value at the other point would be there at negative 4, positive 4. So we don't want to pick those two numbers, because like I said, we're going to be able to reflect these points in a minute. So that's why we pick two numbers either to the right of that line or to the left of that line. So let's start with negative 2. Now, we are going to be using this equation, but I don't want to forget about this minus 5, so I'm going to add that to both sides. So then that way I have all my work on one side of the equal sign. It's going to be negative 2 times x plus 3 being squared, and then plus 5. So I'm going to start by putting negative 2 in here for x. Now negative 2 plus 3 is 1. When you square 1, you get 1. Times negative 2 gives me negative 2. But then we add the 5. Negative 2 plus 5 gives me 3. I'm going to put negative 1 in here now for x. So negative 1 plus 3, well, that's 2. 2 squared is 4. Take 4 times negative 2, that's negative 8. Plus 5 is negative 3. So now I'm going to graph these 2 points. Negative 2, positive 3 would be right about here. Negative 1, negative 3 we'll estimate to be about there. Now the last step is just to reflect these points over that line of symmetry. Reflect that one here because it's 1 unit to the right of the line. I'm going to graph another point 1 unit to the left of the line. Here we have a point that's 2 units to the right of that line of symmetry, so I'm going to reflect that so there's a point 2 units to the left of that line of symmetry. And then we just connect these to make our parabola. And there you have it. So let's do one last problem. Let's go through this one a little quicker. But let's go back and review what we did here. Now you might think, man, that took a lot of time. That was real hard. That was really tricky. It's really not. If you take it step by step, it's very, very simple. We start out by finding the vertex. Take the opposite of what happens to the x is negative 3. The opposite of what's happening to y was a positive 5. Graph your vertex, negative 3, positive 5. Put your line of symmetry down. Pick 2 points to the right of that line or to the left. Put those in your equation. Make sure that you don't forget about, in this case we had that minus 5. Don't forget to add it to the other side so we can include that. Find our corresponding values for y, graph them, reflect those points, and you have your graph. So let's do that for this one now. So again, your vertex would be a positive 2 and a negative 4. I'm going to graph that. Positive 2, negative 4. My line of symmetry is going to be x equals 2. So I'm going to put a dashed line going through where x equals 2. I'm going to pick 2 points either to the left or to the right of that line. Let's this time pick 2 points to the left. So let's use 0 and 1. I'm going to put those numbers into this equation. So it's going to be y equals, because I'm going to get the 4 on the other side, by subtracting 4. So it's going to be minus 4. So I put 0 in here for x. 0 minus 2 is negative 2. Square it gives me 4. Times 3 is 12. 12 minus 4 is 8. Put 1 in here. 1 minus 2 is negative 1. Square negative 1, well, that's a positive 1 times 3 is 3. And 3 minus 4 is a negative 1. So I graph this. 0, 8 is not going to fit on my graph, so we'll just estimate. Here's 6, 7, so maybe 8 would be right about there. Then we'd have 1, negative 1 is right here. Reflect those points. So this one is going to be reflected, so it's 1 unit to the right of the line. This one up here is going to be reflected, so it's 2 units to the right of the line. Connect them, and you have your parabola. So that's how simple it can be to graph a parabola. Let's end by reviewing how to find an equation for a graph that's been translated, meaning it's been moved. So if you look at this graph, here is the original vertex. It's been moved 4 units to the right and 2 units down. So we would say this is a translation of 4 units to the right and 2 units down. The parent function this time is this up here. So I'm going to replace, remember going back to your previous video, we're going to replace x with x minus h and y with y minus k. So it's going to be, my new equation would be y minus my value for k, which is negative 2, so that y minus negative 2 becomes y plus 2, equals my a, which is 1/5, we don't forget about that, times x minus my h value, so x minus 4, and then that's going to be squared. So this equation, if I were to graph this equation, it would give me the green graph over here. Why don't you guys take a second and try this one on your own? So hit pause and then play when you're ready to check your answer. Okay, so this one has a translation of negative 3, positive 1. In fact, they give it away by giving you the coordinate here, because remember that's the point, h and k. So my equation would be y minus 1 equals 1/3, and then it'll be x plus 3 being squared. Okay, so that reviews how to apply translations. If you need more with that, go back and watch the previous video about the graph translation theorem. Otherwise, the key from this lesson was to make sure we know how to graph a parabola by using the vertex, the line of symmetry, picking some points and reflecting them over that line of symmetry, and then you have your parabola. So, good luck with your assignment.